Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 8 from the October 2021 Mechanics M1 International A-Level Edexcel exam. Here we have a question about vectors, and in this question we are told that I and j are horizontal unit vectors directed due east and due north respectively, and position vectors are given relative to a fixed origin. Okay, so at 7 a.m. a ship leaves a port and moves with constant velocity. The position vector of the port is minus 2i plus 9j kilometers. That's the position of the port with, of course, reference to the origin. So from O to that point. At 7:36, 36 minutes later, the ship is at the point with position vector 4i plus 6j. Show that the velocity of the ship is 10i minus 5j. Now, one of the very important equations in these type of questions, which are to do with position vectors of objects that are moving with constant velocity, is this equation r equals r0 plus vt, where r is the position vector at any point that you want, the general position vector of a point, okay, at a certain time t. R0 is the position of the object when time was 0 relative to the origin. This is all of this, and v is the direction and the magnitude of the velocity of the speed. So it's the velocity of the object, okay, that constant velocity that it's moving at. So that velocity is going to be constant, okay, but the time will be changing dependingly, and then of course this will change. This is also going to be constant, the start position. So here we can see when time equals 0, which is going to be at 7 a.m. when time is 0. Okay, it's got the position vector. We say r0 is equal to, now I'm going to write this as column vectors. I much prefer column vectors than ij vectors. So I'm going to write this as at 7 a.m. it's at this point minus 2i plus 9j. I much prefer this. It organizes everything neatly. I components, j components. You don't have to keep writing I and j down. I find it much better to write it in that way. And I know that at 7:36 a.m. okay, now 7:36 is 36 minutes after time equals 0, and they want the velocity in kilometers per hour. This is in kilometers and this is in hours. So let's change this. Let's say this is going to be 36 minutes out of 60. 36 divided by 60. So the time there is going to be 3/5. So that's 3/5 hours. Okay, so that's the time here. So we can say that the time is 3/5 hours. Okay, so we got t and we got r0, and we know we want to find the velocity. Now we know that the position at these 3/5 hours is going to be 4i plus 6j. 4, 6. So therefore we can say that we're trying to find v. What we know is r, which is 4, 6, is equal to r0, which is minus 2,9, plus v, which we're trying to find, times t, which is 3/5. Okay, so if I rearrange this, I can say 4, 6 minus 2,9, just subtract this vector from both sides, is equal to 3/5 times the velocity vector. So we can say 4 minus minus 2 is 6. 6 minus 9 is minus 3. And that's 3/5 of the velocity vector. So if I want to find what the velocity vector is, I have to multiply both sides by 5 and divide them by 3. So it's 5/3 of 6 minus 3. Okay, so we can just expand that a bit. So we say v is equal to 5/3 times 6. Well, 6 divided by 3 is 2. 2 5s are 10. And 5/3 times minus 3 cancel out, giving you minus 1. Minus 1 times 5 is minus 5. So there we have the velocity vector as required. Now I'm just going to write it in terms of I and j. So the velocity is 10i minus 5j. I'm writing like this in the end because that's how they gave it to us in the question. Although even if you left it like this, that would be perfectly fine. Okay, 10i minus 5j, and of course that's in kilometers per hour. All right, then it says find the position vector of the ship t hours after leaving port. So they want us to just basically write the general equation r equals r0 plus vt as we wrote before. plus vt. Now we know what the velocity vector is. We can say the position vector at any point t is going to be the initial position, which was 2, was it negative 2? Yeah, negative 2, 9, plus the time multiplied by the velocity vector, which is 10 minus 5. So again, we can leave it like this, or we can write it as minus 2i plus 9j plus t times 10i minus 5j. You can write it like that. Either way is fine. I, as I said, prefer to leave it in this form. So I'm going to take this form. I think we'll need it in the next question. Let's take all of this to the other side and continue on with the question. Okay. So this is what we know, the position vector at any particular time t. Now it says at 8:48 a.m. So remember, 7 a.m. is time equals 0 is 7 a.m. Okay, that's 7 a.m. At 8:48 a.m. a passenger notices that a lighthouse is due east of the ship. So like this ship is going in this direction. It's going down this way, so 10 minus 5. So it's going like this. Let me make this a bit smaller. So it's traveling like in this kind of direction, like it's going down something like this. 10 minus 5. Okay. And at a certain time, you can say that when this is like when t, say this is when t equals 0. Okay, say the origin is, let's see, it's about here, minus 2, 9. Let's say the origin is about here. I'm just making, it doesn't have to be accurate, but I'm making some sort of a diagram to try and picture what's going on. So this is like minus 2, 9, roughly. Okay, that's the position vector at, that's R0. And then you got the velocity 10 minus 5, 10 minus 5. So we know at 8:48, a lighthouse is due east of the ship. Okay, so wherever it is at 8:48, so let's see, 8:48 is 8:48. Time is going to be, at that time, it's 1 hour and 48 minutes, so that's 108 minutes. So divide that by 60, and that will give you the number of hours. So 108 over 60. That gives you 9 over 5 hours. So it's like 1.8 hours. So that's when t equals 9 over 5. I'll leave it as that so it can help us with the vectors. So now, what we can say is that when t equals 9, at 8:48, t is 9 over 5 hours. So the position vector of the ship is going to be equal to minus 2, 9 plus 9 over 5 times 10 minus 5. That will be where the ship is. So let's see what that gives us. So minus 2 plus, now 9/5 times 10. They cancel, give you 18. 18 minus 2 is 16. And 9 times 9/5 times minus 5, well, 9/5 times minus 5 gives you minus 9, plus 9 gives you 0. Okay, so that means the ship is going to be somewhere almost like basically horizontally across. It's going to be horizontally across from the origin. Okay, so the position vector of the ship when time is equal to 9 over 5, which is at 7:48, it's going to be 16 across 16i. You can say 16,0. That will be 16i, that distance there. That's at 8:48. That's at 8:48. This is at 7. That's t equals 0 when it's at 7 a.m. Okay, so that's the first thing we can see, that the ship is going to be at this point. Then it says at 9 a.m. the same passenger noticed that the lighthouse is now northeast of the ship. Find the position vector of the lighthouse. Okay, so now at 9 a.m. that's when t equals 2 hours. Let's see what the position of the ship is going to be there. You have minus 2, 9 plus 2 times 10 minus 5. Minus 2 plus 20 is 18. And 9 minus 10 is minus 1. is -1. Yeah, that's going to be 9 minus 10 minus 1. So that we know the lighthouse is somewhere this side of the ship. All right, they've told us that already. So it says they notice that the lighthouse is east of the ship at this time. So the lighthouse is somewhere along this line. So I know that the lighthouse, if it's east of the ship, it's going to be somewhere along this line here, somewhere. Okay, now we can try to pinpoint where it is by the other observation of the lighthouse, which is that at that time. Okay, let me just move that up a bit. Okay, so the lighthouse is somewhere along this line, east of the ship, when the ship is at this point here at 8:48, when t is 9/5. When t is equal to 2, when 9 a.m. t is 2:02, because it's 2 hours after 7. At 9 a.m., the same passenger noticed that the lighthouse is now northeast of the ship. Now, northeast is this direction here. There's north, there's east. Northeast means exactly 45 degrees, like on a bearing of 45 degrees. 45 degrees between north and east, halfway. So if we can draw a line, say the ship was here at t equals 2. Okay, if the ship was here at t equals 2. All right, then if we can draw a line from here at 45 degrees, because it has to be along that angle, it has to be 45 degrees, okay, perpendicular to this. Well, it's basically 45 degrees. It doesn't have to be perpendicular to this, but the angle here has to be 45 degrees. Okay, it's 45 degrees, exactly halfway between north and east. Okay, this is going to be the position of the lighthouse. The lighthouse is going to be somewhere along this, so it's going to be exactly along this line. So it's going to be, this line is due east of this point here, and this line is like 45, on a bearing of 45 degrees in this way from this point here, and then that will be where the lighthouse is. So we know that at this point is 18 minus 1. So this is the vector 18 and minus 1. So up to here it's 18, and down here this is minus 1. So let me just do that using a. So this line between here and here, I know it's minus 1. Okay. Now, so this is minus 1. So this is 18 from there to there. So I can just draw this. We can work this out just without even using like vectors, just using some common sense. Okay, if I just draw here, the distance between that point, whoops, that's a bit big, isn't it? What's going on there? Okay. All right, so the distance between, let me put this between here and the origin, okay, we can see that that's altogether 18. So from there to there is 18. Okay, so that's 18 up to here. And this is -1 from here to there. This is the distance between here and here is -1. Now, if this is 45 degrees, okay, this is a right angle. This also must be the same magnitude of 1. So I put -1, but in terms of its magnitude, it's 1 unit long. That's what we care about, the magnitude. It's 1 unit long. Okay, so this is 1 unit long from there to there. So that also must be the same 1 unit long, because this is northeast, so this is 45 degrees. So this must be 45 degrees. Okay, so that must be the same length as that. So this is 1 unit more along. So from here to here was 18. Okay, 18. From there to there you have 18 minus 1. So if you need to go 1 more unit long, it's going to be 19. All right, so it'll be 19, 0. Okay, so that will be then that will be the position vector of L. So we can say that from O to L, the position vector of the lighthouse is going to be 19, 0, which you can say is equal to 19I, no J. Okay, so that's one way of finding the answer relatively simply. Okay, we know the position vector of the ship at this time was exactly east of the lighthouse. Basically, the lighthouse is east of it. So we know at the position vector of this, it was 16, 0. Its position vector was 16, 0, and the lighthouse is east of that. So the lighthouse must also have 0 as its J component, because it's like along this same line, along the I axis, you could say, right? It's from O, right? So it's exactly the same level as O. The lighthouse will be the same horizontal level as O in terms of the components in the J. So that lighthouse is going to be exactly along this line, and then at t equals 2 hours, the lighthouse is spotted to be exactly northeast of the boat. So this angle between the vertical and this line is 45 degrees. Okay, and we know that the vector when t equals 2 is 18 minus 1. All right, that means the line going from here to here must be 1, 1. Okay, 1 up and 1 across. So if it's 1 up and 1 across, then we go 1 up, it's going to join this line again, so that's going to be 18 plus another 1, which is 19 from the origin. I hope that's clear. That's the way that I could think of explaining this in a relatively simple kind of manner. There are probably some vector methods to also find this. You know, you could, for example, find the vector from this point to that point, knowing that it's northeast, and this is 1 unit, so you could say the vector from this point here, let's call this point A and point B. The vector from B to L is going to be I1, 1, you can say, because it has to be, we know that from B to there is 1 unit already, because we know that this vector is 18 minus 1. So B to there will be 1 unit, and that unit has to be the same as this. So it's going to be 1, 1. So you can say 18 minus 1 plus 1, 1. That gives you 19, 0. So we can get the same answer in a few different ways. Okay, so I just basically worked out that must be 1 unit. So we end up with 19, 0. Therefore 19i. So that's the answer to this question, part C. And now for part D. Again, I think we'll need this again. So part D says, find the position vector of the ship when it is due south of the lighthouse. So if we just go quickly back to our diagram, when it's due south of the lighthouse, it's going to be down here somewhere. Okay, so the lighthouse has position vector 19, 0. Okay, so let me just go back. So the lighthouse is here. Okay, the ship is due south of the lighthouse. The lighthouse has the vector from O to L, which is 19, 0, and the ship is going to have a position vector, okay, which we have to find, all right, and it's due south of the lighthouse. Okay, so when it's due south of the lighthouse, then the position vector of the ship is going to be basically having the same I component. Okay, so let's say minus 29 plus t times 10 minus 5. That's going to equal the coordinates of the ship. So let's call the coordinates of the ship x and y. Right? I know that the component of the I component of the ship must be the same as the I component of the lighthouse. Okay, so it must be 19. So I can say that the I component of the ship must be 19. So this must be equal to 19. Okay, because you're going to go 19 across to the lighthouse and then down. It's going to be like the position vector. So this part must be 19. So what I can do is I can work out what an equation from this is going to be minus 2 plus 10t is equal to 19. I can find out what t is when the I component is 19 for this vector, for this where the ship is going through. So this is going to give you 10t equals 19 plus 2, which is 21. So t equals 21 divided by 10, which is 2.1. So 2.1 hours is going to be at that point. So we can work out what this is going to be. Now for the j component of the vector, we can just use the fact that t equals 2.1. So we can say the final position vector is going to be given by minus 2, 9 plus 2.1 times 10 and minus 5. So we know the top, this top is going to give us 19. And what's underneath, we're going to have 9 minus 10.5. 9 minus 10.5. Okay, let's just make sure, whoops, let's just make sure that we're correct there. Okay, take 2. So now to find the y component of this vector that we need, we can substitute t equals 2.1 into this, and we're left with r equals negative 2, 9 plus 2.1 times the velocity vector 10 minus 5. We know that this gives us 19 over here, and we're going to have 9 minus 10.5. 9 minus 10.5 is negative 1.5. So there we have the position vector of the ship when it's due south of the lighthouse is going to be 19I minus 1.5J. And there we have the answer to part D. And that concludes this paper and this question and this paper of October 2021 from Mechanics M1 International A-Level Edexcel. Other questions that you might want to find on this paper can be found in this playlist over here. The rest of the questions, you can find other questions about vectors in, especially about velocity vectors and such in M1. You can find them in this playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching. I hope you found the videos useful, and I hope they're preparing you for your exams well, and I wish you all the best. Thank you very much for watching, and maybe see you soon.